today's briefing is pretty central to some of the work that's going on around OKD and the 4.0 release of it. So we really are thrilled to have Andrew and Brian both here to talk about Ignition and explain what Ignition is. And so I'm going to let you guys introduce yourselves and take it away.
So I'm Redbeard, and I have done things with OpenShift Commons a number of times, been at both Red Hat and Core OS and Red Hat, and am excited to talk to you about different ways of bootstrapping systems here.
I'm Andrew. I work for Core OS and now Red Hat. I'm one of the people that's worked on Ignition a lot. Excited to talk about it too.
Yeah. So, kind of jumping into this here, we're going to go over a whole bunch of stuff, kind of talking about what it is, why it's interesting, why we built it at Core OS, and kind of get into the meat of how you actually need to utilize it to get things done. One of the things that I guess is a great spot to start on here in talking about what is Ignition and what Ignition is not. So Ignition, first and foremost, we're going to be talking about it exclusively here. We're not going to be talking about it exclusively in the context of OpenShift. It's a enabling technology within RHEL Core OS. OpenShift manages indirectly a series of kind of Ignition configs, and that's kind of why this becomes important. At the same time, this is going to be generally useful to folks who become interested in Fedora Core OS and other kind of distros should they choose to adopt Ignition. So what it is primarily is it's designed for the bring up of a host, and it executes on the first boot. For a lot of users who come from the cloud config world, working on various public cloud providers, you're used to, you put in a configuration and it kind of will re-execute every single time you load the host based on the contents of the user metadata. And Ignition does not work that way. It is really just there as a first boot tool. And it is distro agnostic. Now, one important note there is that, it's only kind of embedded into mainly Core OS derived distros right now, but it is distro agnostic. Now, specifying a little more to clarify around that, the configuration, though, the actual asset that you supply to the binary is not distro agnostic. There is the ability to put things in there that are much more nuanced, and we'll dive into some of those details here in a little bit. But suffice it to say that all of these Ignition is something that evolved over time through firsthand learned experience of running lots of RHEL and Debian and container Linux systems, and then figuring out how we wanted to proceed from there. It's intended as a declarative mechanism. You are going to state, or you're going to express the desired state that you want to see. It's not a Turing-complete mechanism, so you're not going to use this and write programs or have loops or anything in it. It is just a configuration syntax, and it's intentionally not Turing-complete to avoid lots of Langsec type bugs and things like that. It operates at a low level. There are just the primitives there to get things done, and then we at Core OS and Red Hat have implemented a number of higher order tools to allow you to then render the Ignition configs that you need. And it is extremely strict. We wanted it to operate in a very deterministic way. so that you didn't have to worry about, or I guess I should say, it is not as forgiving as it could be because we wanted it to fail in very obvious ways. So I guess.
Yeah. And as a note on that, one of like Ignition's mantras is it should give you the system that you asked for, or it should give you nothing at all. It should never give you a like partially configured system. So if your system comes up, you know that it has the state that you described.
Yep. So Ignition is not a configuration management system. It's not Chef or Puppet or Ansible. It is just there to bootstrap the host. So you're not going to decide that you need to change the configuration later after the host has been up for 3 weeks. If you need to make mutations to the host, then go make the mutations to the host. But Ignition has nothing to do with that. And it is not an installer like Anaconda. You can use it to build an installer. You could have Anaconda do something where it rendered, or I should say the front end to Anaconda rendered an Ignition sequence and then executed it. But we explicitly didn't want it to be something where we were shipping an installer on every single host. We wanted it to be something that was a very basic mechanism for bootstrapping and kind of building the distributed systems that you were trying to get to. So at Core OS, it was specifically started by two gentlemen, a guy named Vito Caputo and Alex Crawford. It now is maintained by the platform engineering team, specifically the Core OS tools team at Red Hat. So in the context of what it can do, it is all of the basic things that you would need to kind of bring up, and I understand that I keep saying the phrase like use it to bring up a host or bootstrap a host, but when you think about the opinionated way that Core OS has done things, for anybody who's used OpenShift v4, that, we have done a lot of dictation around like, okay, you should configure your network interfaces in these ways. You should kind of set up the system tunables in specific ways. We felt that we wanted to have the mechanism that could do all of that setup, but also was free enough to kind of configure anything else. So, hypothetically, being able to use the same configuration mechanism to bootstrap Kubernetes, as well as bootstrapping hosts for running Apache Mesos or running OpenStack. It's kind of intended to be very generic in what it can do. So, whether that's the setup of disks, wiping partition tables or kind of making new file systems, kind of handling the basic user and group creation, laying down files on the file system. These are all things that were first order, kind of very important components to be included. Where it begins to differ a little bit, though, is that it understands how to both do the normal things of like loading its configuration from disk or from cloud metadata, but in the case of specific hypervisors like VMware, QEMU, etc., it can actually pull in the configuration from the hypervisor itself. And another kind of key decision that we ran into after working with the immutability of auto-scaling groups on AWS was that we wanted to make sure that you could chain load and merge other Ignition configs. So, you can take a data URI, of either kind of embedding data in line to include more Ignition content to be able to merge that in, or being able to reference a different network endpoint to be able to load the config. So you could imagine, having a stub config in stub ignition config that you boot cloud provider hosts from, that then chain loads across to your configuration server so that you could endow identity over time as you recycle those hosts, etc. And it can even kind of handle varying versions of ignition configs, kind of including pulling in newer versions. And I'll let Andrew speak to that for a moment.
Yeah, we're actually going to get to that later.
Okay, great.
Yeah. This is also useful if you have large configs. Like some cloud providers, you don't get a whole lot of space in your user data. And so you can have a small config there that actually goes and fetches your large config from somewhere else.
Yep. So getting into the question of why it exists, I can tell you that the second week that I worked at Core OS, all of us went out to Lake Tahoe and locked ourselves in a cabin for a week to push out the first kind of major set of improvements to Core OS, which later became Container Linux. And I was standing on a table yelling about how I didn't want to have different configuration domain-specific languages for cloud, for physical machines or machines running on a cloud provider. Like, I was tired of it. I didn't want to have to deal with kickstart files and cloud configs. I only wanted one thing. And so the first thing that we did at Core OS was we rewrote Cloud Init, which is the thing that runs cloud configs on OpenStack and a number of cloud providers. It's the agent that runs on the host. And we rewrote it in Go so that it was statically compiled and made it work everywhere. But it was ultimately a bad idea, not because it did the wrong things, but because folks were too tempted to use it as a configuration management system. It became very easy for them to go, oh, I'm just going to, twiddle this config, and now I reboot the hosts, and all of my, root passwords are updated, which is a great example of exactly the thing that we didn't want folks to do, because it's one, don't set a root password. Two, why are you using your bootstrapping mechanism as configuration management? So we decided that, we had to start over from scratch, and we needed to be able to support the sorts of things that Anaconda did and the sorts of things that Cloud Init did, but on clouds and physical machines. That was, still one of the guiding principles. So, that's why we kind of re-envisioned Cloud Init as Ignition and kind of started from there with this configuration mechanism. So Ignition configs are versioned. They are declarative, both of which we touched on briefly. Most importantly here, they are JSON. We wanted something that had a much, much stronger typing system than YAML did, which is the kind of configuration or the, framework behind cloud configs. And we also needed to have a validator. So, we wanted them to be versioned so that we would be able to improve and extend it over time, while being much more clear around what the contract was with backwards compatibility. And then having the versioning there with the validator then allows us to actually lint the spec and everything else much, much, much easier. So I think at this point, this is a good opportunity to hand things across to Andrew to let him talk more about the configs and take it from there.
Yeah. So the first thing that you should know about writing Ignition configs is you shouldn't write them. You should let other tools write them for you. The configs themselves are JSON, which is already kind of a pain to write. Things like inline files need to be URL encoded or sometimes base64 encoded. Things like systemd units need new lines escaped, and it's generally not a great experience. So OpenShift will generate them for RHEL Core OS. For Container Linux, we had a tool called the Container Linux config transpiler that generated them. And that would take a document that was a YAML specification and then translate it to a Ignition config. And that also allows us to keep Ignition still low level with only primitives, but also add sugar for things like common tasks like configuring etcd. For Fedora Core OS, we're rebuilding the CLCT, but for Fedora Core OS, and that's the FCCT, and it's the exact same idea. It's also a YAML document. It's a lot easier to write. And if you do end up writing Ignition configs for whatever reason, validate them. Because when Ignition fails, it fails hard, and it fails in the initramfs, which means it's a little bit harder to debug than a lot of other tools because you fail before you have SSH up or like fully working consoles or things like that. So we have a web validator that you can use, and then also on the Ignition releases page, there's binaries you can use as well for validating your configs. And that'll catch a lot of problems that would otherwise fail on first boot. So this is just an outline of what the spec looks like, just the high-level parts. There's a top-level Ignition section. This is where we specify what version the config is. The config section there is where you'd specify either if you want to replace the config that you're using with one that you'll fetch over the network or merge in additional configs. There's a section for timeouts for if you want to change like the HTTP timeouts for fetching things. There's a section for adding additional certificate authorities, and this is used by Ignition. So if you need to fetch a resource over HTTPS, but the cert for that is like custom to your organization, you can specify it there. The storage section is relatively straightforward. There's a section for doing things with disks, like partitioning them, creating file systems, creating RAID, creating files, links, and directories. All those are pretty straightforward. System D units have their own section because we also allow special things for like enabling or masking system D units. And then finally, there's the password section for creating users and groups. One note about that Ignition section. Everything there is just for Ignition. It does not actually affect the system that you're configuring at all. So if you need to add a CA cert there and you want it also on the host after you're done configuring, you need to specify the cert in the Ignition section and also write out the cert in a files section. One potentially confusing bit is Ignition is versioned and its spec is versioned, and they're independent from each other. They're both Semver. So there's two main versions of Ignition. There's the 0.x series and the 2.0 series. The 0.x series supports the older specs, which go from V1 up to V2.4 experimental. And the new Ignition V2 supports the new spec V3 and newer versions. You'll note that there is no Ignition V1, and that doesn't exist because of Go semantic imports, where it'll treat V0 and V1 as the same import path, so you can't import the same. You can't import both if they're one is V0 and one is V1. So that's why we skip straight to V2, because those will give us the ability to do that. And how this works under the hood is internally everything gets translated up to the most recent version. So if you hand like Container Linux or Arcos a V1 config, it'll internally parse that and then translate that from a V1 to a V2 config, and then from a V2 to a V2.1 config, etc., up until you get to V2.4 experimental, which is the latest config it supports. And this happens immediately after the config is parsed, and so this is how you can have an older config like merge in a newer config, because internally that older config gets translated up to the most recent version. It'll then fetch the newer config. It'll also get translated up, and then the merging only happens on the most recent version. One big note is the older configs, the V1 through V24 experimental, and the new V3 configs are not compatible. There were some bugs in the config specification that were not fixable without a compatibility break. So right now, RHEL Core OS and OpenShift use the old version, but those will move to V3, and Fedora Core OS started off with V3.
And that's actually a good area to just kind of reinforce what Andrew mentioned earlier, is that, that's also why we wrote the tools like CLCT and FCCT, because they are intended to kind of mask some of these annoyances to make it so that you don't get caught up as much in like the nuances of a giant blob of metadata sitting in a JSON file.
Yeah. So this is an example. This is actually a container Linux config, but the container Linux configs are mostly additive on the ignition config, just in YAML. So this YAML, you can imagine, could be transcribed into equivalent JSON. And all this does is add an SSH key for the core user and adds a user, the Harrington, and adds an SSH key for them as well. And one thing you'll notice is missing from this container Linux config is a variant. So since this is just using the ignition parts, this is actually relatively portable. You could use it for RCOS or container Linux. But if you specify this variant and version, that doesn't actually mean anything. It has no concept of a variant, and the only supported version is version 0, and we just put that in there as a way to reserve the keyword to make sure people weren't using it. And this was largely a mistake, so you can't do that with container Linux configs. So now I'll show you a brief demo. Give me 1 second. So
Need to make that bigger too.
If I need to make it bigger, I need to kill the thing and reopen it. Give me 1 second to make my terminal bigger. That's not. Is that better? So I'm in the Core OS SDK here, and I'm going to use this tool called Cola. And Cola is our testing tool for the various Core OSs. And it has a subcommand spawn. And what this is doing is generating an SSH key pair and generating an ignition config that adds the public key to the authorized keys file, and then logs in over SSH with it. And if I go and look at the ignition config it used, I need root to look at it. You can see, let me use JQ actually. You can see it's got a version, and all it does is add the SSH key so I can log in.
Yep, pretty straightforward.
And if I look at the journal, you can see that ignition, in fact, did run. All right.
And you can see in this case, actually, as we mentioned, kind of pulled it directly from the hypervisor.
Oh, yeah, pulled it from the firmware. And if I go back over to the slides. So as another example, this is for Fedora Core OS. This is a Fedora Core OS config. You'll notice that there is the variant and version this time. We did not make the same mistake twice. And I'll dive into exactly what this config does in a sec. But to look at what this would be rendered into, if you run it through FCCT, you get an equivalent blob of JSON. So this is pretty much the same. That's not always the case because FCCs can add sugar for things. And you'll note also the version is not the same. If I go back, you'll note this is version 1 and this is version 3. They're not the same, but every FCC version maps to a Ignition version, so it'll always deterministically give you the same config. And so every FCC that's version 1 will always generate a version 3 config. And if we dive into what exactly that looks like, there's really 3 parts. There's a part here where we're saying the device dev VDA should have a partition number 5 with the label var, and the start and size are 0. And these are actually special values. Start 0 means find the start of the largest block of available space on disk, and size 0 means use as much as possible. So this just creates the largest partition possible on the disk.
Now, one question for you. I noticed there that, you said that, starting at a block. Are we making decisions like doing the right thing and aligning on, 4K block sizes and things like that?
Ignition is v3 actually only supports aligning on megabytes, so everything is aligned automatically. And you also don't need to specify like partitions that are already there. You're just specifying like what you want on the system. So next, there's we say that there should be a file system. It should be XFS. It should be on that partition we just created. That's what that part label /var is for. We're going to label this one as var, and then when Ignition runs, that file system should be mounted to /var, and that's /var in the system you're configuring. And then finally, we say that there should be a system D unit. That's just a mount unit to mount that. And you could also do this by like appending a line to like etc/fs tab. And so now as a quick demo for that, go back to my terminal. And I'll run.
As an aside, you get to see behind the scenes of some of the various engineering tooling that we built, that we have for actually doing the assembly of
What's the file called?
The Core OS and container Linux images, as well as what we use for testing them.
Yeah, and so this here is going to run a Fedora Core OS build I have and pass in the Ignition config. And I'm also saying that we should resize the disk image beforehand to make it 16 gigs instead of the default 8. And this will give us space for that var partition. So if I run this, it's going to take a moment. And this is actually running in a container as well. So if you notice, I passed in the Ignition config as /srv/demo.ignition because that's where it's getting mounted into the container. So now we're going through the boot process, and this is just on the console. And now we're in. And so if I do journal control again, you can see again that Ignition did run. A bit more logs because it's a more complicated config. If I run sgdisk and look at the partition table, I need root. You can see that it did in fact create the partition. If I run lsblk with file systems, you can see it is in fact XFS.
Labeled var.
And it's labeled var, and if I run find mount, you can see down at the bottom there that it is in fact mounted to /var. And if I look at the Ignition config in there, you can see it's got a bunch of other stuff we didn't specify as well. So it has everything we specified, like the disk with the partition, but it also has these other files.
And the data URIs, which are one of the things that we mentioned in the beginning.
Yeah, so this, writing to the basher C, we're appending this, and we don't know what this is because this is base64 encoded. We could go look at that if we wanted. But what's actually happening here is when I ran that, when I ran this, the tool I was using to run it actually embeds the config that you specified as a merged config into a base config that does things like turns on some things for your terminal, sets up auto login. Like that's what this is here.
Yeah. All the things that you need specifically to do development for
yes.
the operating system.
And I can actually look at the config that was passed in. And if I look at that, you can see here it has a merge line for this giant base64 encoded blob, and that is the blob that of the file that I passed in. And so if we look at what we actually did here, so this is mostly a normal Linux boot process where you have, your firmware load, your bootloader. This might be EFI or BIOS or a device tree blob, and then that loads the kernel in initramfs, and that might be grub, might be your bootloader.
Yeah. I mean, to clarify on that, everything that we are working on is all focused around grub. The U-boot and mentions of device tree blob are there, talking more aspirationally around, showing how other distros or other chip architectures could utilize this in a very similar way, because ultimately that's all the setup before we get to the things that Ignition really cares about.
Yeah. And then kernel will unpack the initramfs, and this will run the init program from the initramfs. And if you're not familiar with initramfs, they're basically a root file system that gets bundled with your kernel that is used typically to find the device and set up the device that contains the rootfs, so that can be mounted, and then you switch root into your real root on disk. This is useful for things like if you don't have a kernel module in your kernel and need to load that before you can load your root file system, or if you need to do things like decrypt LUX or turn on RAID or things like that. But we looked at that more as a space that you can do things before the root device is mounted. And this is how Ignition gets away with running on first boot, but still being able to repartition disks or create RAID or things like that. And so after we're done in the initramfs, that mounts the real root to /sysroot and then switches root in there. And when you do that switch root, you exec your real init program. And that's just a regular exec, not a fork and exec. And so your real root's init program replaces the init program from the initramfs.
And so just to clarify, if another distro wanted to kind of pull in Ignition, they would be able to take the binary, add it to their initramfs, and then run it via whatever mechanism they use to run applications in the initramfs.
Yes, and we actually have the Ignition-specific Dracket modules for pulling Ignition into your initramfs if you're using Dracket, split out from the Fedora Core OS specific ones. So you can pull in Ignition that way. There might be some work you need to do to get it working with your specific distro, but... and if we dive into more how Ignition works, it has two main stages. The first one is disks, and this is everything that needs to happen before you mount the rootfs. So this is things like partitioning, RAID, and file systems. And these are all things that you can't really do if you've already mounted it, so that needs to happen first. And then there's the file stage, which operates on the rootfs and optionally other file systems you've specified. And this is where we do things like create users and groups, create files, systemd units, etc. And then new with Ignition v2 or the v3 spec, there's also these two stages, mount and unmount. The mount stage, it mounts all of those file systems you specified. So in our example, we had the var file system, so that's where that gets mounted. And then afterwards, after the file stage runs, we actually unmount it. And that's really important because we want to make sure the first boot doesn't succeed just because Ignition ran. We want to ensure that the first boot is representative of all of the subsequent boots. So you don't get a system that worked on first boot and then you go to reboot and then it fails. We want to make sure that you've configured your real root to mount everything that it needs to, and it's not just being passed through when you switch root. And so if I go back to that demo, and I look at the journal logs again, you can see here at the start, let me go all the way up. You have the disk stage first, so you see all this disks, and that's creating the partitions and creating the file systems. And then after that, you have the mount stage that runs, and this is very short because all it needs to do is mount the var file system. Then you have files, and that goes and creates all the files and units we specified. And then finally, we have the unmount stage at the end. So at this point, we'd like to open it up for any questions. Want to leave some time for this. I'm not sure what's the best way to get the questions.
So at this point, this is where we asked Diane for a little bit of help, and she...
I'm right here. And there are a couple of questions. Dale was asking a question regarding when this was going to land or be used by OpenStack, I think OSP. And I'm wondering if you have any insights into that.
So that is going to be up to the OSP developers. I think that right now, especially since they're still kind of getting OSP 16 ready, which is going to be the next LTS release, they're probably, which if I remember correctly, is shipping early next year. They're probably still in flight with all of their existing processes. I think more interesting to that is when Ignition was going to be available, if it was going to be available in one of the RHEL Classic.
Yeah, I don't know about that, but yeah. With regard to OpenStack, Ignition already supports OpenStack. It views OpenStack like a cloud. And so OpenStack has like two main ways of passing in a config. You can either do it over network or via a virtual disk device, and Ignition actually supports both. So
yeah, I guess
because all a cloud provider or hypervisor or anything like that needs to support Ignition is just a way of handing us the config. There's no other interaction between the cloud or hypervisor and Ignition.
Yeah, clarifying. I was talking about what you would use to actually bootstrap OSP, and that's still kind of forthcoming for supporting a machine atop OpenStack that's long been available.
Cool. All right. I think that was part of the question was the role Ignition would play and when, and so I think you've answered that quite nicely. So another when question that I have, and I don't know if you have any insights in it, but what timeline will OpenShift be moving to V3 of Ignition? Do you have any ideas or thoughts about that?
I think it's at either 4.3 or 4.4. I don't remember which off the top of my head.
Yeah. Okay, but it is in the timeline, and it's probably sitting somewhere in some Trello roadmap document that we can dig up somewhere. Yeah. Okay. I knew that I'd heard it, and it came out as part of the conversations around OKD 4.0 as well. So that's it. So I'm looking in the chat now. There's a whole bunch of you on there being very quiet. Somebody's asked a question. Frerk, in one of the config examples, he saw a network D section, but not in the earlier overview of the common sections in ignition config. Is that a special case or something in development?
So Container Linux supported, like the only way to configure networking on Container Linux was via network D. And as Ignition initially started out for Container Linux, we had special keywords to support that. With Fedora Core OS, we actually removed that because Fedora Core OS does not support network D. Instead, you should be using Network Manager. And also, everything that the network D section was doing was just writing files that could be done in the files section. The system D section is a little bit different because with system D units, you can do things like mask them, enable them, disable them, etc. But network D units are not the same. So that's a difference between the spec like 2.x and the new spec 3.
Did that answer your question? Yep, looks like it did. Perfect. So Charo is asking a question which I think is on a lot of people's mind. With FCOS needing Ignition v3 and OCP 4x needing v2x, he's assuming that poses a challenge for OKD 4x working group. And the short answer is yes, it's all a matter of timing and design documentation. You want to add anything to that, Andrew or Brian?
Yeah, I mean, I would say there is not the differences between the configs and the config syntax is far, far, far outweighed by the similarities. I can say I mostly got hung up in some of the early RCOS testing because I was able to just literally take vanilla, ancient Container Linux configs and run them through a validator and they would work. Now, ultimately, then what happened was having the kind of very basic configs that I wanted to use and running those through the updated config transpilers took care of the lion's share of what I needed. And, even when I then had my RCOS configs that I started using with Fedora Core OS, which used a different version, it was mainly, okay, just take it. I have to go grab FCCT and then run it through FCCT, and it warns me, hey, I see a couple issues. You're obviously trying to do this other thing, and you intend to do this, so tweak X, Y, and Z. And that was the kind of sugar, or part of the sugar that Andrew was talking about earlier, because having the config transpilers made that transition much, much easier. So, while it's going to require testing on our part, and it's going to require effort from the Core OS engineering team, it should be a relatively smooth transition for users.
Yeah, and to add on to that, most of the issues, like where they are incompatible, are from places where people are doing weird things with Ignition configs and exploiting the bugs in the spec. So Ignition, we say that the Ignition config should be declarative, but there's parts of the v2 config that are not declarative. It's possible to specify that something should be both a file, a path should be both a file and a directory. And what actually happens there is that's the behavior there is determined by the fact that Ignition happens to create directories before files, and then the file can overwrite the directory. But what really should be happening there is the Ignition validator or your FCCT validator should be yelling at you saying, this isn't possible. You're saying that one thing should be two different things. I can't do that.
Yeah.
So that sounds like it answered everybody's questions too. So it's good. And as Charo says, he doesn't mind doing a bit of hacking early on. And I think all of us expect a bit of that. I had a question, and I don't see any other questions in the chat, so we're doing pretty good. But I had one more question for you guys working on Ignition. You keep talking about it being done by, all the work being done by the Core OS team. Is there any way that other people can get involved in working on this? And if so, how do they do that? How do they connect with the people working on Ignition if they want to work on that?
One thing that I will mention is, of course, Diane, we're going to pass the slides to you, and all of the slides there on that question section have links to the upstream repositories and the validators and everything else. So, they are open source projects, and, we love to have contribution from the community. I'll let Andrew speak more to the specifics and tactical portions.
So the pretty much all of our development just happens directly on GitHub. We're not in secret meetings off to the side, deciding the fate of it. Most of it happens just as discussion in the issues section. There's two repos that are very important. There's the Ignition repo itself for the actual Ignition binary,
which is github.com/coreos/ignition.
Yep, and that'll be linked in the slides when we send those out. And then the other is ignition-dracket, github.com/coreos/ignition-dracket. And that's where we keep all the Dracket modules that support Ignition being able to run in the initramfs. Both of those also have two branches. The master branch is for the new Ignition v2 and spec v3. And then there's a spec 2x branch for the older version and the older spec, because those are maintained both for RCOS and for Container Linux. So if you go check them out, just make sure that you're looking at the right branch for what you want to contribute to.
Perfect. And I think actually Philip has another question. The network manager config in FCOS is quite complex. It might be opportunity to work and collaborate there. Are there any plans to make it as easy as in Container Linux?
Yeah, so that's something that actually should live in the Fedora Core OS config transpiler, because that is distro specific and it's sugar, because ultimately what you do to configure Network Manager is write files. And so that's something where the Fedora Core OS config transpiler should support a easier format and possibly even support validating that, depending on technical questions there. And then generate those Network Manager configs for you.
Okay, and there's some more questions coming in, so this is great. For someone who is familiar with Kickstart, is there a good starting point to transition to Ignition, as in a quick start for Kickstart users?
There's no specific guide for that.
Yeah, I mean,
That sounds like a good blog post.
Yeah, it's because the thing is with Kickstart is because there is not an ordering to it or any type of real hierarchy. It's something that actually, it's kind of like you could make something that translated an Ignition sequence into Kickstart, but not really going the other way. It's largely I guess, a blog post makes sense because there's certain things in a Kickstart file that you would just go, okay, you don't care about this, ignore it. Other things that, make sense, and then some of the things like where you would have a post section, the way that would manifest is you would take the script and embed it as a file in a data URI, and then you would create a systemd one-shot unit to actually execute that script. And the kind of rad thing about that is you're able to use the primitives there with systemd to actually do proper ordering or dependency management. So you would be able to say, even if you wanted to have 6 different scripts, but all running in a specific order and making sure that, they come up after a specific, mount point has happened or a specific socket is opened, all of those mechanisms are going to be there. And that's, again, kind of why we did all of that in that way. But yeah, it looks like we're going to have to draft somebody, and I'm going to have to talk to Ben about making that happen.
Something to add
that'd be
there
great.
as well. Like Kickstart supports some things that like Ignition does not and will not support, like things like configuring bootloaders or things like that. Ignition is very much designed for their operating systems that follow a similar model to Container Linux and the Core OSs, where you have a disk image, and that's up on the clouds as your AMIs or GCE images or whatever. And on bare metal, you also have that same or very slightly modified disk image that your install process is just DD the image to disk verbatim and inject your config into the boot file system so Ignition can find it. And that's how we unify both the cloud and the physical machine scenarios. But that also means that like there's parts of that disk that you're not allowed to mess with, like the bootloader, for example. And so it's not quite a one-to-one replacement for Kickstart.
Yeah, I guess that also touches on, I guess, some of the differences in ideology. Container Linux was not a general purpose Linux distro. Like, it was not intended for you to grab it and run GNOME on it and things. I mean, I know David Michael from the Core OS team definitely did that, and it was amazing to see, and so did Jess Frizzell, but like, that's not how it was intended, and we always said, if you're looking for a general purpose Linux distro, Red Hat and Fedora and Debian and others are out there, go seek them out. And that kind of touches on, like, Ignition can do things like lay down your vimrc and create all of your users and stuff, but it's designed, like, it's serving Core OS, whose goal was to build distributed systems, not systems that every user within an organization have their own account on and log into. It's there to build the robots, not yeah. But so that's kind of what drives some of the ideologies there in the why of how things work.
Yeah.
All right. Well, we have one more question. Ryan's asking for any tips on setting a host name using v3. And is it just right to the etc host name? And I think that might be our last question for today.
Yep, it appears that's the case. Right to etc hostname.
I like simple questions.
Yeah.
That was great. So
basically,
all right.
Ignition doesn't prescribe any like way of doing things on your OS. It gives you the tools to do things the way like those upstream tools are designed to be configured. So in most cases, that's just writing out a config file. So there's nothing special about like Ignition writing out etc hostname. Like you use Ignition to do the things you normally do. There's no like Ignition specific quirks about like writing out specific files or anything like that. And so the short answer is yes, just write etc hostname. But the long answer is if your distro wants you to configure the hostname in a specific way, you should use Ignition to do it the way your distro wants you to do it.
Yeah. So if FCCT or if Fedora wanted you to specifically kind of run hostname CTL instead of running that, that's the thing that FCCT should be doing, so that you can just say, my hostname is, foobar, and then FCCT will generate the systemd unit to kind of take that and lay it down, or put the config file in place, or whatever else needed to happen.
Yeah.
All right. As Ryan said, this has been a great demos and a great conversation. I'm just adding the OKD working group link into the chat. So if anyone is interested in the OKD working group and continuing on the OKD side of these conversations, please do that. Chuck is asking if we can provide links to FCCT and CLCT as well. So if you guys can gather those up, I will distribute the recording. It takes about an hour or two for it to process, and then I get to download it and upload it again into YouTube. So we put all of these videos on, as some of you know, on RH OpenShift on YouTube, and put them. I'll send them out onto the mailing list for the OKD working group and for OpenShift Commons, and tweet the heck out of it. So you'll see them soon. And if there's other mailing lists you want me to post them to, please let me do, or just post them yourselves. Cool. And we'll have you guys back, I'm sure, because I think this is going to be something we, as Ignition changes and grows and matures and does other things, we're going to want to hear more. So thanks again, Andrew and Brian, for taking the time today.
Of course. Be seeing you.
Yeah. See you.
All right. Take care, guys.
Bye-bye.